Hello and welcome to today's webcast. My name is William. I'm part of the product marketing group at GitLab, and I'll be your host today as we talk about digital transformation in general with a particular focus on cloud native transformation with special guests Ask Media Group and AWS. Before we kick things off, I'll cover a few quick housekeeping items. First of all, please do ask questions throughout the entire session today. You'll find a Q&A function at the bottom of your screen where you can ask questions about the content. At the end of today's presentation, we've reserved some time to answer your questions. As well, you'll find a chat box where you can send messages to panelists and your fellow attendees. Go ahead and use the chat box now to say hello and let us know what part of the world are you tuning in from. We tend to get folks who join from all over the place, so it's always interesting to see. It looks like Mark has weighed in, thank you. Michael from New York, Sean Ram, a lot of folks joining in. Thank you. Please do continue to chat and ask questions throughout. As I mentioned, our special guest today is Ask Media Group. AMG is joining today to share their cloud native journey and how they've used both GitLab and AWS to drive digital transformation and cloud native transformation. You might remember Ask.com as a search engine, but today Ask Media Group operates over 30 different websites internationally across 15 locales. They produce a wide variety of content from enriched search results to articles and galleries, along with shopping sites. And across their properties, they get over 100 million unique visitors per month. So they operate at a very large scale, which increased the challenges they faced when transitioning from a traditional software model to cloud native. With that, I'd like to introduce our speakers. Chenglim Ear joins us from Ask Media Group, where he is a principal software engineer. Chenglim leads the development of microservices in the cloud, utilizing modern tools and platforms such as GitLab, Kubernetes, Docker, and AWS. And Trevor Hansen is a solution architect at Amazon Web Services. Trevor works with AWS partners and customers to adopt new technologies and to drive digital transformation. With that, I'd like to hand it over to Trevor to talk to us about what he's seen in the AWS ecosystem in regards to digital transformation. Trevor?
Excellent. Thanks, William. Guys, it's absolutely amazing to have all of you join us today. It seems like you guys are joining from far and wide, some people late at night, some early in the morning. And this is something that, we're seeing day to day. And I could imagine each of you are seeing this in your day to day, from the applications you use to the transportation that you're using to essentially every single customer experience has been continuously improved and iterated on based on the technology that's driving it. And this is something that we really want to unpack in this journey. So this is something that, as a partner solution architect, I work really closely with software companies, and I'm seeing this transition happening on a day-to-day and how we're empowering developers to be able to improve that customer experience, to be able to release software a lot quicker, and essentially being able to leverage cloud services and the tools provided to us for developers to be able to improve that functionality. So let's take a quick look something. Excellent. So what we're seeing is, go back to the slide. Modern applications. Great. So the way we're seeing these applications changing is, modernizing these applications, moving away from that very monolithic application where it used to be that snowball effect where you're continuously growing that one big application. The blast radius when anything goes wrong is really, really impactful. And it's something that we're seeing, moving to cloud, really breaking things down into that microservices architecture and leveraging things like serverless, moving towards these containerized solutions and abstracting away from, these potentially having to deal with all the little levers at the bottom. You can actually use the right tools and processes to be able to put things into, production, and ensuring that the best version of your application is out there serving your customers. So as I explained, we initially come around, we sit and we look at, what are the tools and services available to us in cloud and technology today for us to be able to reinvent, what we're currently doing, continuously think of, what are the tools out there that can allow us to develop a lot quicker? How do we improve that experience for our customers and allow developers to be able to use these tools to improve that experience? And this is a continuous innovation flywheel. And, the scariest thing about, moving to any using cloud services or, breaking things up into these microservices, when you start scaling, you want to make sure that you have a consistent experience. You want to make sure that you got the right things in place to make sure that, there's a cookie cutter scalability solution. There's nothing worse than scaling and, you're not having the right visibility or having the right tools in place or processes in place to be able to make sure that when your code is out there in production, you're making sure that you are 100% confident that it's getting out there. It's not going to, have any issues out there. You want to make sure that customers are experiencing it the best way possible. So, we've seen this whole transformation, and we've seen from, where you previously used to have to just install, you have to set up a server, you have to go install the operating system, make sure that all the dependencies are there. And eventually, you have the development team that hands over, some code, and you're trying installing this, and it becomes a bit of a nightmare to manage. Over that transition, we're starting to see, this amazing solution coming into play, and it's this whole concept of, containerization. This allows, obviously that consistent experience, and I could imagine, a lot of people joining today are experiencing containers in some way, where it be, you haven't actually touched it at all, or to your full container workload, you clearly will start seeing the benefits here. Being able to, take a carbon copy version of your code, being able to define it as, as a single template, providing this to a cluster, and being able to scale that across, multiple different nodes, and allowing you to actually, scale to meet your customer's demand, making sure that you're scaling the consistent experience, giving each customer that same experience. From the back-end side, containers is no doubt something that's really easy to implement and easy to scale and ensure that you got that consistency going there. One thing to mention, if you started playing with it from the first day, you do see that, it becomes a bit of a nightmare to make sure, what version's running where, how you're making sure that that application is scaling correctly. This is when tools become essential to this, leveraging things like, GitLab, being able to make sure that you can manage that cluster. You have confidence in making sure that you've got the right pipelines connected up to your cluster to essentially ship the best version of your code. This is something that Chenglim from Ask Media is really going to unpack, and how they've actually experienced this themselves. So as I previously touched a bit there, you can pretty much define your application and dependencies as code. You pass that to the cluster, and the cluster knows exactly where to grab that carbon copy of that code. As I mentioned, if you want to scale this infinitely to be able to deal with this in different locations, it's super easy. Once you've got a really good working production in one area, you could pretty much replicate this to other regions, or you could essentially just scale that out. It's really easy to manage that microservices. As I've mentioned, as soon as you add more into the mix, it may seem like, you're breaking down that monolith and you're moving to that microservices. Containers allows you to be able to have that consistent experience, and you no longer have to deal with, like herding cats. You actually, your confidence in the ability, because your containers, that when it is running, you're making sure that you have that consistent experience there. And that's, as I mentioned, is the standardization of that. As I mentioned, version control is something that's really important here, is when you actually have those containers put together, you're pushing out that code out into that container, and you can actually make sure that whenever you're shipping things out at large scale, you can actually be able to leverage the right tools to make sure that, what application version is running there. You're collecting the metrics and logs from those containers for the applications that connect to that, to ensure that, you're meeting security, you're meeting compliance and those things. And there's a lot of areas that we can talk into that. But from, as I mentioned, on AWS side, we've spent a lot of time working on making sure that, containers can be run in any capacity. From your side, you may be thinking you don't want to use, specifically, as a service. You maybe want to run it on your own, your own servers. that's something that you can move over to doing on an EC2, or you can actually move over to something that's more of our managed services, which you're seeing with Elastic Container Service and our EKS service, which is our managed Kubernetes service. And then we also have options like Fargate, which is additionally another abstracted version there. We have obviously quite a bit of services that connect into that to allow you to be able to do that monitoring, being able to ship that code into that container, and then ensuring, security and compliance and those things. But my day-to-day job is working really closely with our partners that enable us to be able to do things on containers in the most creative and scalable ways. Empowering developers with the right tools to be able to get this job done really easily. This is something that I'm passionate about, and on a day-to-day, I work with companies like GitLab to ensure that from AWS side, we really working together to make sure that customers using these services in combination are getting the best experience possible. So as we have covered this a couple of times, I'm sure a lot of you have seen this, and I could imagine you're all in different phases of this journey, from that monolith application to microservices breakdown. This is the true benefit here, is being able to take things, divide it up, move it so that each software team or program that's managing application is responsible for their own workload. They have sort of that DevOps methodology in place, and they have the right tools in place to be able to leverage things in the cloud, and essentially using things like, serverless and microservices and containers to be able to do that. So you really have a lot more flexibility when you're moving them. If anything goes wrong with the particular microservice, you're actually not going to be able to bring that whole monolith down. You're only going to maybe have small functionality that may be at problem. But because containers, is really easy to get up and running, it's very easy for you to be able to replicate maybe to a different region, to be able to get yourself up and running really quickly. So being able to not just reduce the blast radius, but being able to make sure that you can get your application to scale up and down when needed, being able to ensure that you have the right load in the right regions to support customers in those particular areas. This is what Ask Media should be covering in their components. So I could give a lot more context there, but if you guys have any questions, please feel free to drop it into that chat. This is obviously a really important area for you guys to look into, being able to transition into that microservices architecture. And I'll be handing over to Chenglim from Ask Media that will be talking a bit about his journey and how they've done this transition, and essentially using GitLab to be able to enable that functionality for them. So over to you, Chenglim.
Thank you, Trevor. Hello, everyone. Thank you for joining us today. My name is Chenglim Ear, and I'm a principal engineer at Ask Media Group. When I joined AMG a couple of years ago, a plan was in place to migrate all hosted services to OpenShift, a flavor of Kubernetes. And I set up a service mesh using Linkerd before the term service mesh was coined. As one of the principal architects of our microservices platform, I'm particularly interested in making microservices development easier using building blocks. In the next half hour, I'd like to take you down our journey and tell you about how AMG transformed our self-hosted system to a cloud-native system on AWS. So let's start by asking why we did this. Over 2 years ago, we had many reasons to change so that we could grow our business. It's actually a pretty standard story. We make money through advertising by bringing up an audience to a lot of published content on the web. The options available for drawing users to our websites were changing, and we had to change to stay in business. But really, a lot of things got in the way. Routine tasks like onboarding developers or releasing software took too long. Our monolithic systems limited what we could do, and we were paying for unnecessary resources to support our VMs. Change was slow, difficult, and costly. And so we changed that. Change was the root reason for change, so we needed a system that could handle change. When we look at what we did to speed up development, make development simple and transparent, and control the costs, we see a paradigm shift. GitLab gave us push button releases. Docker and Kubernetes enable us to switch to a microservices architecture, and AWS enabled autoscaling. Suddenly we found ourselves in a situation where we could do a lot of things very differently. Things became more dynamic and more automated, and we found new patterns and practices that we could pursue. So on Amazon, we started building clusters, Kubernetes clusters. And GitLab, as you can see, became our command and control interface. Before joining AMG, I heard a story about a Spotify developer who hooked up a push button to their automated deployment system. And I thought that was I thought that kind of self-service was pretty cool. Today, we take for granted that every deployment is triggered by a virtual button that is enabled through GitLab CI. With Gitlab Runners on Kubernetes and AWS Spot instances, we even have an auto-scaling cluster of containers doing work for us. To explain how we did it, let me borrow from a metaphor about the rider, elephant, and path. And you can find this in a book called Switch, How to Change Things When Change is Hard by Chip Heath and Dan Heath. The rider represents that part of us that needs a clear understanding of what the change is about. And so a couple of years ago, we set a goal at AMG to move to a variable cost structure so that we only paid for what we needed. We also wanted to be able to quickly scale up development of new services to keep up with the changing business landscape. And all that made a lot of sense to us. Now, the elephant represents the emotional part of us. We really needed to feel good about the change. And so the thought of self-service, independence, and new technology gave us the right feelings. But to finally really have change happen, we really needed to clear the path. Remember that we were not just moving software from one place to another. How were we going to be successful building software and using practices that were unfamiliar to us? And at the same time, stop trying to build software the way that we had gotten so good at doing. The answer the answer has to do with building blocks. But let me just explain this with an example. Well, let's suppose that we're being asked to create a system that will automatically review the content in a CMS within a day and annotate the content with errors, the score, and the recommended action. As experienced developers, we might see that we simply need a server process that will follow the logic in this sequence diagram. And this monolithic approach might look something like this. We might choose an object-oriented language and organize our code within the repository so that it can be easily maintained and can grow with enhancements. At the same time developing this, while developing this, we probably feel pretty good about it. And we probably feel good because we put a lot of thought into the design. The problem, however, comes later. As we are trying to scale the monolith, we might find that maybe the software has passed through too many sets of developers. Each of them enhanced the software and added their favorite patterns and features from the latest version of the language. Maybe the code base has gotten so big that it takes weeks to get familiar with the overall structure and months to become the developer answering the questions about the software. And maybe our concern about breaking the software unexpectedly becomes the major factor in deciding what enhancements we are willing to make. Or maybe for the changes that we want to make, it takes months of discussion before we break ground. if there are problems with monoliths, is microservices really the answer? Well, if the microservices approach is to just break up our monoliths into smaller monoliths and putting them into containers, aren't we just creating more work for ourselves? And the answer is yes. To build microservices, we actually have to think more about just more than just about making things smaller. At AMG, it's about decomposing a monolith into different types of services and creating collections of services of the same type. If you do this, the complexity does not grow beyond the number of types, even when you are developing hundreds of services. What you want to think about is building blocks. Servers, workers, and applications are the typical types of services in a system. Those types of services make up the name of our platform for building microservices, called SWAP. With SWAP, we can build many services of the same type by cloning existing projects called archetypes. This is how we clear the path for change from building monoliths to building microservices at AMG. But let me show you what I mean by taking you on a test drive. So what I have on my machine is an instance of Gitlab with a runner so it's not going to be able to run a lot of processes in parallel. But first, let's take a look at our requirements for the system that we have to build to annotate content in a CMS. We've already done this or talked about doing this with the monolithic way, which was to take all this logic and put it into a single process. But what if we decomposed it a little bit and just kind of look at this sequence diagram? What we want to do is pull content from CMS to read it, basically, and then try to annotate it with some checks on the content. In my example, I'm going to annotate by checking the grammar and the spelling of the content. And then we're going to collect all the results after annotation, the scores per annotator, and come up with a final score and make a recommendation as to whether or not to continue to pass the review on to a manual review or to just simply accept it and move it forward. And all those results will then be written back by a writer to the CMS in the same document where the content came from. So let's suppose we took a different approach, and instead of putting it all into one big bucket, let's actually build each individual piece independently. And in this microservice approach, we would start by creating projects for each of these actors in this sequence diagram. So before I start, let's actually look at our projects, or the group in which we're going to create projects. So in Gitlab, I have a demo group where we're going to create these projects for these different different little services, microservices. And as you can see, there's nothing there. And typically what you would do is you would click the new button, new project button, and create a brand new project for every one of these from scratch, empty projects, and then start filling them in. Well, with SWAP, the strategy is to start with something that actually works rather than start from nothing. And so what we have in our system is a collection of archetypes. And so you can see a few of them here. Today we're going to use the job archetype and the pipeline archetype. And these are actual GitLab projects that are fully functional. They don't do much, but they have the bare minimum infrastructure in which you can build from. And so let's do that. Let's create these projects the SWAP way. So I have here a little tool that we have, and we're going to create 1, 2, 3, 4, 5 projects using the job archetype. And there we go. We've set in motion the process for creating those projects. It's going to talk to the GitLab API, and it's going to start creating those projects. I also need a pipeline project to kind of bring it all together. So I'm going to use the pipeline archetype. And I'm going to call it content pipeline. And I'm going to submit that too. So while that's going, and you can see one's got created already. If we want, we can just take a quick look at that. And so this is our reader project. But before I get going and actually do some development, let me just go back and talk a little bit more about what we're going to be doing. So let's take a look first at the CMS. We're going to be reading from a CMS. So I have an example CMS here. In our example CMS, we have 4 content, 4 documents here. Some with bad grammar, bad spelling, some with a little more text. So this is our content here. And so if you look at the one with the bad spelling, you can see I've spelled a lot of words wrong. And then we have perfect ones, which we'll expect to have a perfect score. And our score is going to be from 0 to 1. So the perfect score is going to be 1. So at the end of this, our system's going to go through all these documents and provide the recommendations and the scores. And in fact, also include in the document itself all the detailed annotations that was produced. So let's go back. That's our CMS, and we'll get back there when we're done. So while we, before we start coding here, we're going to take a look at our set of projects and how it's going. So it looks like 3 projects have been created. So let's go to the first one, reader. I'm going to open it up in a new window so I can just get rid of it when I'm done. So you can see it's already got files in it. It's actually a full functional project. So if you try to build it, it'll successfully build. But the code in there is pretty minimal, right? It's just putting out some text here. So what I'm going to do is I'm going to code, but I'm going to cheat a little bit. And what we're going to do is we're going to just paste in some code that I've written earlier. And so this reader needs to talk to the CMS and get the content. We want it in JSON form. So we're going to just use a basic curl tool. It's just a bash script. Nothing too complicated, so there's no need to build any complicated code here. We're going to hit a URL and grab all the content, run it through JQ, put all the JSON objects into a file called input.jsonl. And that's going to be important later when we try to process the content. So this is going to get stored somewhere. And so let's save this. And let's look at our next one. So let's take a look at the spelling annotator. I'm going to open this one directly in the editor this time. And so this time we are going to put in some code to annotate the content after looking at the spelling. So this one's a Python code. The great thing about microservices is that you're not bound to one language. And so you can have the executable is in a Docker image. It gets brought up in a Docker container, and then you can execute it. And so we're putting into our Docker image this time. Every one of these projects, these job-based projects, they build an image, and the script that we're editing ends up in that image. So this time we're going to put, instead of a bash script, we're going to put in a Python script. That's because there's a nice little package out there I found to do spell checking. So I'm going to import that in Python. I'm going to pull our input JSON-L file that's created by the previous job. And then I'm going to produce the result in a new file called spellingannotator.jsonl. So in my Python code, I'm looping through my input content. There's like 4 of them, each a JSON. and we're going to pull that content, and we're going to pull the words out of, we're going to split the content here and pull the words out of that and run it through the spell checker and get the list of ones that are misspelled. And then we're going to put out a message for each of the misspelled words on what it should be spelled as by making use of our spell checker. And then we're also going to calculate a score. And it's a very simple algorithm here. You get deducted 0.1 for every misspelled word. If you got too many, it's just 0 is your score. Then we construct the result of our that we're gonna of our annotator, and we write that into our new file, the spelling annotator JSON L file. So let's save that. And so you can imagine that in this process or in this approach, because we've broken it down into multiple services, they can actually all be developed independently. So you can imagine, I've created 6 projects here, and they can be six developers creating these projects independently. And so there's the only thing you need to do is coordinate, okay, what file are you going to create so that I can pull that file and process it. But otherwise, and swap handles the passing of the files across to the services, so you don't have to worry about that. So let me just continue now to the grammar annotator and then quickly just update that code. And it's pretty much very similar to the other annotator. This one is pulling in a language checker tool, also written in Python, and doing the same thing, coming up with the score and putting it out into a different file. And then the scorer. Scorer, I also wrote it in Python. I read in the annotation files. I'll be producing an output file, collecting all the results from the annotators, coming up with a recommendation, producing some result that's going to be used to update the CMS document later when the writer runs. So you can imagine that the annotation and the scorer are code that could get pretty sophisticated and may require some expertise, like from our data science team, to build those types of services, who are more familiar with, how to, if we need some checks that are very specific, that require sophisticated data science knowledge. We can have the data scientists working on these projects, while things like the reader and the writer, as you can see, was written in Bash, can simply be done by somebody else with less specialized skills, development skills. And so you'll see right now that my writer is actually just a Bash script, and I'm just gonna call curl again, and this time I'm actually going to update my CMS, which is right here in this location. Okay, now the fun part's going to start. Once you have all these little subservices that's going to do these little specialized or focused, perform these focused functions, we're gonna piece them all together with a pipeline. So I'm going to go directly. Well, let me take this. Service, this is the thing that puts it all together. And so what we're going to do is we're going to leverage GitLab CI. So in GitLab, there's this file called gitlab.ci.yaml, which is a configuration file that's to configure a pipeline, a CI pipeline. Well, we're going to use a CI pipeline to actually run those jobs in a pipeline. And so the way GitLab CI works is you can configure what CI jobs to something that looks like this, and you could put a bunch of these in there, and then and hook them all together by specifying when they're going to run, setting up stages where they run, and specifying which image you want to pull in to execute, and then what script to run in that image. So in this case, we don't want this pipeline. We want our pipeline that's going to pull in all those services that we've just created. And here it is. So you can see we have our reader, our speller, our spell checker, our grammar checker, scorer, and our writer. These are the images that have been added to the GitLab registry for those projects. And we're going to pull them in, and we're going to add them to our CI job. So there's one for the reader, one for the spell checker. And for each one of those, we're going to execute the script. Through this script, we'll end up executing the script that we had modified. So I'm going to commit that. And then we're going to see how things are going. So as I made those code changes, you can imagine in parallel, right, multiple developers working together. These code changes are being compiled or are being packaged into images, so you can see all that got done while I was working on my stuff. So all in parallel. Now the pipeline is set up so that it doesn't run when you make a change. It's gonna we do that on purpose because we want to be able to decide when we run this pipeline. In particular, we want to be able to schedule it. So I'm going to open up the scheduler for the content pipeline, and I'm going to create a schedule. And just a little something to tell Swap what to do when we run this. And right now, we're not going to actually run it on a schedule. We're going to manually activate it. And so the nice thing about the GitLab schedule is that you actually have a little button right here where you can manually run the pipeline. So it looked like all our jobs built successfully from the status that we were looking at earlier. So I'm going to go ahead and run this. And so when the schedule is running, there's this nice little link to the CI pipeline. And you can see you can get to it through here. So this is what we just configured. So from building a monolith where you have to go in, build code, and deploy something and have it running and ready to receive requests, what we've done is we've built a bunch of microservices, and it's just building images. Nothing's getting deployed. And we went and we created a configuration, and still, again, nothing's getting deployed. All we did was configure a pipeline. And from that, we're able to execute code to perform the function of the system that we want, and only use resources as needed when it's running. So only right now when it's running, what's happening is the GitLab runner is being called on to pull in that image into a container and to execute that code to perform the function that each of these buttons correspond to. And then once they're done, the resource is freed. So we're only using this much resource right now, just what's needed for this guy, which is really nice. And one of the big aims or goals for us was to minimize costs, to not be using resources and paying for resources when we don't need it. And so this is a really great pattern that enables that. And right now we're building a system that is a batch processing system. The same thing applies to real-time system with request response. Same kind of pattern. You want to build little microservices, and then you want to wire them together. And there are a lot of advances being made right now in the Kubernetes world to be able to only use resources as you need them. And so our pipeline is coming to an end, and you can see that it is at the point where it should be writing to the CMS. So let's go back And let's take a look at our CMS. And okay, it finished. So just so you can see, if we look at our status, we can see that the pipeline actually finished. And we have our scores here. And if you go into one of these, you can see that this particular content has a lot of spelling errors. And here's our little text that we put together to suggest what the correct spelling should be, and the score that this annotator gave out, and then the final, and then the grammar annotator also had a score. There was no grammar errors, but a final score was calculated and a recommendation was created. And our perfect one got our perfect score of 1. That is pretty much the demo for now. So let me go back to my slides. See if I can make this full screen again. So we took a look at really what it looks like. The annotation pipeline that we built demonstrates a microservices approach that can be used for building many systems, as I said. Imagine being able to add more annotators or other services, you know, just like building blocks, right? Adding them like building blocks. Adding a service is just a configuration. There's no need to deploy anything, and no resources are used until the service runs in the pipeline. If this was a monolith, we would likely be paying to keep a VM running 24/7, even when we don't need it. So the microservices approach is to decompose the problem. By decomposing the monolith into microservices, we're making the hidden logic transparent, and we enable the parts of the logic to be independently developed in parallel, right? So you can have developers all working on their own with different skill sets. And so we actually did something like that for real. So this is a scaled down version of something we've done here, where we had data scientists working on the annotation part, and then we had just back-end engineers working on the input and output. And you can imagine, you know, you can have various skill sets within your team. And somebody could set up a pipeline. And in fact, we set up a pipeline even before we had the various services built. So we compose solutions by wiring together reusable services instead of filling up new buckets with a lot of code that only a few can understand. And so you can GitLab CI and create a pipeline. So what's next? What's next for AMG? Spot instances and GitLab pipelines are key enablers for us in our new world. So we want to stress that you know, with Kubernetes, we're able to auto scale and leverage spot instances with AWS giving us that capability. And so that controls our cost as well with spot instances instead of having to pay full price, basically. So we plan to to make the most of both the spot instances and GitLab pipelines as we enhance our Kubernetes clusters and continue our transformation. Oops, sorry. In the meantime, let me hand it over to William. I believe we're going to do some Q&A.
Hey, thank you, Chenglim. I think what you're doing at Ask Media is so exciting, and it's something that I see all the time with enterprises and businesses of all size transitioning from monolith and adopting Kubernetes and cloud native. And it's this, as you and I have chatted, it's the idea that you want to empower development teams to own their service, but they don't have to be the Kubernetes experts. You have a team that's built out a platform to enable each of those teams. And I've seen this pattern over and over again of operations teams that are kind of building this abstraction layer so that each service can get an archetype or a template for their service. And what you've done here is just really exciting because essentially there's two layers of pipeline. where you're using a pipeline to go and grab the project template and spin up, here's an archetype service. Now I'm a developer and I can just go and run with that. And then you're also using a pipeline to then compose those all together.
Yes, it's very powerful what we can do with GitLab.
Yeah, I think that's a really innovative use, and I've seen the pattern a lot. But what you're doing at Ask Media is really neat. We'll have questions that continue to come in via chat and the Q&A. One of the ones that I'm curious about is, what were the pros and cons that you weighed when you were choosing GitLab and AWS?
Yeah, so I think probably the big driver is that we wanted to move over to microservices. We wanted to leverage Kubernetes, and so it was a new container world that was shaping. And so that when we looked at GitLab, it seemed it was very complete in providing what we needed to be able to build containers or build images to run on containers. It's got that built-in registry, and so it you know, and the CI pipeline was really powerful stuff. And so that was pretty much a very big deciding factor, that GitLab, you know, had everything that we needed. Other options maybe had some good stuff, but didn't have some other stuff. And then with AWS, it was kind of the same thing. We wanted something that we wanted a product that was fairly complete and mature. AWS has a lot of history, lots of services, as was demonstrated earlier by Trevor. And so we definitely wanted to be able to leverage those services and to be able to build on a platform that was solid. And so we set off to build a Kubernetes clusters right on EC2 instances. And until this day, we continue to look at opportunities to leverage the resources available through, or the services available through AWS.
Yeah, I'm curious, as you're going on that journey, at what moment did you start to feel we've really made the right decision here?
Well, I think for me, as with GitLab, for me, it was when I got to that point where I had a button that I could push as a developer to deploy, and it was so easy to do. As a developer, that was my moment where I said, this is the right thing to do, right? This is very empowering for me. So GitLab is an empowering product for developers. And so I think for me, that's a moment, and I would guess that was a moment for a lot of people when they got their work made simpler and easier. That was probably the moment. And then AWS, I would say that, you know, AWS has a good history, track record, right? So it doesn't take much to see that they're pretty solid. So once we start using it and it's working great and it's doing what we want, I think that speaks for itself already.
And I'm curious, it sounds like in the journey there that it didn't necessarily all come all at once. There was a portion where you were running in an on-prem data center and you maybe adopted containers first and learned that practice before then shifting that to the cloud. Can you talk a little bit about that, what that journey looked like in the order of operations?
Actually, you know what, I think my boss described it as doing things in flight. You know, that idea that we're flying and at the same time we're trying to like build this thing that we're flying in or something. And so it was a lot like that. We actually did the whole container thing as part of the migration. And so it you know, although we did run, I believe, a OpenShift Kubernetes cluster on our own hosted system first, and before we moved it onto Amazon. It was all kind of this part of the same migration, and so it wasn't a lot of time, right? We didn't like bake it into our hosted system before moving to Amazon. It was more like getting something working and something that could be transferred, getting into that form, preparing it to be moved over. And so it was a lot like just keeping our fingers crossed but I think probably the main thing that really made it work was that it was a all hands on deck kind of process. And you know, it wasn't like just a small team doing this. the whole organization came together, and it was a collection of people together, everybody watching a piece of it and making sure that everything was covered, that brought us to the finish line. And it was a exciting moment when we finally were all on AWS and we turned off our hosted system.
Yeah, that one of the most powerful things I think about Kubernetes is that portability. The idea that you can build and implement a system and that sits as an abstraction from your infrastructure. So that idea that there was an order of an operations, there was, okay, we're going to learn containers as an organization first, and then we're going to move to the cloud. But the work that you put into doing that on-prem transferred over, and it felt like one continuous process.
Yeah, it wasn't really so much learning about containers first. It was, let's learn containers while we're migrating. That was what it was like.
change the tires on the bus while it's driving.
Exactly. And we did it. So it says, I think part of it speaks to the technology, like you said, right? It's a really good technology, container-based development, building blocks. You know, once you have that kind of stuff set up, then it allows you to move much faster.
Well, another question I would love for Trevor to hop back in here. Some of the discussion in chat and such has been around what are the different types of industries that can adopt microservices on Amazon? And in particular, when you're in an industry like, let's say, telecommunications, it's very sensitive to latency and delay. Have you seen those industries also adopting these types of architectural patterns?
Yeah, so firstly, I'd like to start off, Chenglim, you did a phenomenal job there showcasing that journey. I would just like to echo one of the answers you said that, you know, containers has really empowered this ecosystem of all these companies and, you know, partner solutions that allow you to be able to make this a lot easier for you to do that, right? There's, you know, much like we start using the programming languages that get a lot of traction because there's a lot of interest in them, meaning that companies develop the right tooling to make it easier for you. And this whole abstraction layer and, you know, moving to the cloud and being able to leverage, you know, containers in the cloud and using, you know, partner tooling like GitLab, you know, this basically allows you to focus on what's critical for your business, right? You don't want to, you know, come up with an amazing startup company and thinking, you know, we're going to do this in our own capacity and we're going to try scale this. The last thing you want to do is scale the problem with you, right? You want to be able to, you know, abstract away from all that pain points and the nuances of, you know, having to figure out how to fine tune things underneath the hood when you could just be focusing on leveraging the right tools that allow you to feel like, you know, you're able to do the flight simulator because it's helping you throughout that journey, right? You know, I've heard lots of analogies around, you know, you're changing the wheels on the bus, so you're trying to, you know, fix the ship while it's sinking. But like at the end of the day, you really want to be able to abstract away from all the noise and having to administer all the, you know, that pains that come with infrastructure and being able to leverage cloud and scale up and down. And based on what Chenglim had mentioned there, you know, cost is a driving factor for everyone. Yeah, you know, cost, speed, and functionality. And that's something that each of our service teams from day one, before we launch any service, that is the tenets that we need to be focusing on, making sure that customers can scale really quickly. We can work really closely with them to ensure that, you know, they can not have to pay for resources they don't need to be using. And containers is perfect for that. You know, containers, you know, you have that flexibility to be able to scale up really quickly and scale down when it's not needed, and being able to do things in a very time-sensitive manner. So over to the, you know, the industry side, you know, AWS, you know, I'm fortunate to be working with a lot of companies that, you know, are dealing with very time-sensitive issues. You know, they want to make sure that latency is extremely, extremely low. You know, they're able to scale at a rapid rate. And this is something that, you know, I work closely with our partners, with our service teams in pretty much every vertical and industry at the moment. So telecommunication is one, no doubt one that, I don't know if you've seen any of our videos at reInvents with Annie Jassy and Vanna Vogels and, you know, the services and things we're launching. But this is something that, you know, it's really important to us for our business that, you know, regardless what industry and what challenges you face in this industry, whether it's compliance, if it's security, if it's latency, whatever it's going to be, we want to make sure that our, you know, our platform is the place for you to be running those workloads with confidence. I will drop a couple of links in the chat for everyone, you know, around some case studies in telecommunications. But at the end of the day, you know, just like we work closely with our partners, if there's a reason, that you're feeling that you're struggling to make that transition to like, how do we run workloads in the cloud because we have some concerns in some areas, we have specialists that, work with these industries on a day in, day out, and they actually help them through those migrations. They would more than happy to have discussions with you, sit down, understand your problems, recommend the right partner tooling that can complement that transition for you into cloud, and just giving you that better experience. Whatever cloud platform you're moving into, you want to make sure that you're enabling teams to be able to do the right thing with the right tools. And as we saw in this demo, GitLab allows you to have a single button. You're able to configure what happens after that button. And that, there's a lot of power that happens underneath there. It allows you, you're moving away from this very painful development teams having to stress and be on call. Now you're actually, allowing yourself to iterate and release code at rapid rates into production, and knowing with confidence that, you've got platforms that are ensuring that everything's going to continuously moving in the right direction with the right monitoring to make sure you're not moving in the wrong direction there. So, it's fantastic to see Ask Media making these changes. I know that it's not easy as sort of, let's flip the light switch and just go all in, let's go containers and change that. It's definitely a journey. And it's a journey where you need to obviously sit down with the right people to help you think, prioritize, think of what's the best path here. And I think this, this Ask Media and GitLab and AWS coming together is one of many steps that we're taking. We put a lot of content into blogs, to webinars and those things. But at the end of the day, if you have any critical questions that are not answered, reach out to us. We want to help you guys. This is something that we really want to make sure that every company that does this transition succeeds. And this is something it's merely maybe just pointing in the right direction or putting you in contact with the right person to make that happen.
Yeah, that's phenomenal, Trevor. Definitely, even as you were bringing in earlier, the value proposition of owning your business logic and abstracting away the undifferentiated engineering that you would have to do. That's what these types of technologies and the value of driving cloud native transformation is, the idea that you can not just save costs on the infrastructure, but even in your staffing and human costs, that the engineering time that you're spending on building differentiated logic and driving business value is really powerful.
I think back to that one slide that I had, that innovation wheel, I think to really sum that up is you want to be able to have speed at a low cost, right? And if you can spin up that innovation wheel as fast as possible, that is where microservices becomes the crucial component. Containers allows that whole, move at a rapid pace, and being able to keep that at a low cost. That is what is this whole transition we're seeing in, this digital transformation. So I'm really happy about this.
Well, there's a few more questions. We only have about a minute left. I would love to show actually one thing before we close it out here. We did have a question just about some other GitLab features and the type of roadmap. And so what I'd love to round it out is just show here. Are all seeing my browser window now? Is that right, Trevor?
Yep, we can see your browser.
Yeah, so here on our homepage, one of the things that's unique about GitLab is that we put all of our roadmap and everything publicly. And so if you look at, we've got functionality across all of these stages, and you can go here to our coming in 2019 in our create stage. And here's where we have something like, let's say, our web IDE functionality. This is not something we covered on the webinar, but for any part of GitLab, you can go and check out our vision. So here under the vision shows our roadmap and how we're developing this product. And so one of the things that we love to do at GitLab is, just as we've done today with our partners and our customers, is what we call co-creation, where together we're really driving these exciting new innovations in the industry. And so at GitLab, we love to put everything out there publicly, including our roadmap, including our project management, so that customers, users, and anybody in the broader GitLab community can go and comment and engage with. And so that's something we're really excited about as we even see what's even like the next stage of the journey beyond cloud native. So with that, I would love to just say thank you to everyone for attending, and hope that everyone has a wonderful and pleasant day. Thank you.
Thank you.